Volume of prisms. Okay, so common metrics for volume are cubic kilometers, cubic meters, cubic centimeters. So they're going to come out cubed, which kind of makes sense because a cube is a solid, where a square is a flat. So when we do the conversion, we actually have to cube, usually from kilometers not cubed to meters is 1,000, but we're going to actually have to cube that as well. So a cubic kilometer is actually going to be this, Wabinga cubic meters. So it's a big conversion. So we have to be careful when we do those conversions. For capacity, capacity is like volume, but it's measured in something special that's sort of already three-dimensional. So you've heard of liters. You might not have heard of kiloliters. Oh, you did. We did it last year. And milliliters. So these are all these are capacity words, and cubic things are volume words. So if you have the volume of 1 cubic centimeter, you've got a capacity of 1 milliliter. So they're just a little bit different in nomenclature. 1 liter is 1,000, careful, 1,000 cubic centimeters. So it's not a cubic meter, because a cubic meter to a cubic centimeter, sorry, the other way, is this. So we got to be careful. Okay, so volumes of solids with uniform cross sections, which means they don't have any kind of bumps along their, what we might call their height. If it's a triangle through and through the whole way. If they have a uniform cross section, it's the area of whatever that is. If it's a triangle on the side or a rectangle, times the height. Okay, the volume is the area times the height. So if we look at a regular prism, a cuboid, we have the area of one of the sides, which is length times width. If it's a rectangle, or if we took the squares, it wouldn't matter, because we're going to end up doing length times width times height. Couldn't be simpler. We're going to do a similar thing with a triangular prism. We're going to use the area of the end, which in this case is a triangle. And so we have 1/2 base times this height, height 1, times the other height. So we don't confuse them. We call it height 2, and that's going to give us our area. So firstly, we're going to convert this 2,000 cubic millimeters to cubic centimeters. And I'm going to go up and double check and get rid of some of this guff. I'm going from cubic millimeters to cubic centimeters. So I'm going to divide by 10 to the power of 3. 10 to the power of 3, or any number 10 to the power of something, is 1 with that number of zeros. 10 to the power of 1 is 1 with 1 0, so it's 10. So in this case, what did I just say it was? 1,000. So if I take 2,000 millimeters cubed, wow, and I divide that by 1,000, because that is 10 to the power of 3, that gives me 2 cubic centimeters. Find the volume of this three-dimensional object. Well, volume equals area that we know of the one end times the height. So we're told already that we have 3 meters squared. So we know that that is square meters already, times 3.5. Therefore, our volume is going to be 10.5, and the unit will be meters cubed, cubic meters. Find the volume of this prism. So the volume equals area times height. So we're going to find 1/2 base times height. And you know, sometimes I like to do base times height over 2. And we'll put height 1 on there, because 3 is going to be height 1, times height 2. And 5 is going to be height 2. So 1/2 base times height. Volume equals 30 cubic centimeters. Finally, the volume of this rectangular prism, we know that volume equals area times height. Well, in this case, if we have a rectangular prism, we can use length times width, that will give us one of those areas, times height. So it'll simply be, I can choose any of these because multiplication is associative. So our volume is going to be 15 centimeters cubed, or cubic centimeters.